So for non-concurrent force system, so again, this is the time that we're going to be using the three equations. So we're going to be utilizing the two directional equilibrium equations. Summation of forces x equals 0, and then summation forces y equals 0. And the third equation is summation of moments at a certain point is equal to 0. So again, they are all equal to 0 because our system is in equilibrium. So meaning balance siya, di ba? Balanced. Okay, so in this example, so again, we're still going to solve the reaction at A. So A is a hinge support as dictated in the problem. So the boom AB is supported by a hinge support A, and then a cable which runs from C over a small pulley at D as shown. So compute the tension T in the cable and the horizontal and vertical components of the reaction at A. So neglect the size of the pulley at D. So we're going to solve for the tension, this portion here. So the pulling of this tension cable. And we're going to solve for the reaction as well. So reaction forces horizontal and vertical because again, we are dealing with two equations. Okay, so to start off is if we try to draw the FBD separately, so let's try to draw it on this portion. So pasensya na sa drawing again. So if this is 2, then this should be the cable here. And then again, since it's tension, it's pulling upward. That will be our T. This is 200 pounds. This will be 100 pounds. And then the tension at cable T is unknown. So this will be T. And then we're going to have two reactions. Oops, sorry. Okay, so summation forces vertical. We don't know yet. So let's try to figure out our equations first, starting off with summation of forces x equals 0. So for summation of forces x equals 0, so we're going to have two horizontal forces, and that will be coming from the support at A sub x. So that will be A sub x since that one is going to the right, and then the other one going to the left is the component force coming from the tension cable. So since this one is diagonal, so again, as what we have learned from our previous discussion, so we can resolve this one into its components, its horizontal and vertical components. So how do we do this is, again, since we have this distance, 8 and then 2, so we can create a right triangle here and use ratio and proportion. So 8, 2, so this will be, ilan na siya, ang hypotenuse. So that will be square root of 80 or 4, ito ba? 8 squared is 64 plus 2 squared is 68 eh. So square root of 68 eh siya. So 2 square root of 17 din eh. So this will be 2 square root of 17. And then of course we can create another triangle. that will represent the force triangle of the tension. So this is T, this is the vertical component of the tension, this is the horizontal component of the tension. So through ratio and proportion, we can determine the value of your vertical and horizontal component. So, to do this is we're going to first get the ratio of the, so since we are interested in x first, so we're going to get this ratio first. That will be T x over 2. And the next is the tension, then together with this one. So equals T all over 2 square root of 17. So if we're going to multiply 2 to the other side, so T sub x is equal to 2t all over 2 square root of 17, then cancel out 2. So we're going to have t all over square root of 17 as your t sub x. So meaning we're going to subtract t sub x here because it's going to the left. So the value here is t all over square root of 17 equals 0. So notice that we have two unknowns so far in our equation. We're going to let this one be the first equation. So next is summation forces y is equal to 0. So we're going to have an upward force, two upward force coming from the vertical reaction from A, and then the vertical component of the tension coming from the cable. So positive value will give you positive direction, diba? Then plus, so this time is we're going to determine next the vertical component. So make a ratio first between the y direction, so that will be ty all over 8. Then the tension cable as well equals t all over square root of 17. So t sub y is equal to 8t all over square root of 17. So this will be 8t all over square root of 17, and then minus 200, then minus 100 equals 0. So combining the equations is we have a sub y plus 8t all over square root of 17, and then minus 300 equals 0. So this will be our second equation. So two unknowns still in the second equation. So next is we're going to use the third equation, which is the summation of moments equals 0. So summation moments at A, di ba? Sorry. So let me erase this one first. Kaning atong mga pang-declare there sa right side. It's okay, murag di kita sa akong mouse pointer. Okay, so summation moments about A is equal to 0. So if we're going to look at the diagram, in kaning isolated diagram here, so what will be affected by the moment is just the vertical component of the forces, while abot ang horizontal because it's in line with the point of the moment. So if we're going to solve this one, is we're going to have first is get the moment of the 200-pound force. So again, if you try to push 200 pounds with a 2-meter distance, so I mean 2 feet distance, so the rotation will be clockwise, diba? So this will be negative 200 times 2. And then for the next part is ang vertical component ra sa tension is affected by the moment because this distance here multiplied by the vertical component of the tension, so it will create a counterclockwise rotation, di ba? So for the horizontal components, it's in line with your point A, and again, the distance should be perpendicular to the force. And if you try to look at the horizontal component of the tension cable, it is collinear with your line of action, diba? It's collinear with the distance, so we cannot include the horizontal component of your tension cable. So ang vertical component lang. So since this one is counterclockwise, so again the vertical component, as what we have solved earlier, it is 8t all over the square root of 17 and then times 4. That's the distance. And then lastly is minus, so going towards the last weight, that will be 100, then multiplied by the 6 distance, so multiplied. So again, if you push the distance against the tail of the force, it will create a clockwise rotation. So this will give you negative moment. So this is negative 100 and then times 6 equals 0. So notice that in our third equation, so we have only one unknown compared to the first two equations, which is two unknowns. So with this, we can now solve the tension with the use of your calculator. So 200 times 2. So let's try to so ato siya i-correct ang atong answer kay murag sayop niya atong kanina. So going back to the triangle again, so sayop to akong ikuan. So 4, 8, and then this should be square root of 80 din siya. So tx, ty, and then t. So tx over 8 equals t over square root of 80. So this will be tx equals, so square root of 80 is, so nag-flip ko sa distance. So this is 4 square root of 5. So 8t all over 4 square root of 5. So tx is equal to 2t over square root of 5. Another. Then for ty is ty all over ty din akong i-solve dahil ty ni siya. Table na akong apel. And then for tx over 4 equals 4 square root of 5. Pala noon. paano kaya nasayop ko declare sa ako ang distance. So ty all over t all over 4 square root of 5. So tx is just t over square root of 5. Now, so if we're trying to correct our other equations, so ganina is nasayop ko ganina. So akong gibutang sa triangle manggod ganina is 2 and 8 manggod. Yeah, ang atong distance diri is 4 dai. Nya akong gibutang dito is only 2. So that's why it was wrong. Muna akong gi-correct karon. Okay, so for the y component, this is 2t square root of 5. So if we try to again use po ng other terms here sa atong x and y. So this will be for the x component t over square root of 5, and then this is 2t over square root of 5, 2t over square root of 5. So solving again our tension, so this will be 279.51 pounds. So we now have our tension T, tension from the cable, and what's left for us to do is just use equations number 1 and number 2 to solve for the reactions at A. So solving first for the horizontal component using equation 1. So using equation 1, so this will be AX equals AX minus T over square root of 5 equals 0. So AX minus, so again our tension is 279.51 all over square root of 5 equals 0. So AX equals 125 pounds. So for the vertical component is we're going to use equation number 2. So I think we don't have any more space left. So again, you use equation number 2 here to solve for, so 2 times 279.51 divided by square root of 5, then minus 300. So AY is equal to 50 pounds. So this one is using equation number 2. So ana lang sa siya kay nagwa na tayo space to solve for. All right, so do you have questions or clarifications? Okay, so Lara, so let's proceed with the next number. So this time is we're going to solve for the supports again. So we're going to have one vertical component here at A. So this will be AY. And then for the hinge support is we're going to have two supports here. One is vertical, then the other one is horizontal. So I just made it going to the left because I observed that there's a 240 pound force exerting on the right side. So meaning for it to be in equilibrium, so it has to oppose that direction, going to the right. So this one should be going to the left. Then this one is, so let's say this one is b sub y. Okay. So the easiest way that we can solve this problem is we take moment first at b, so that we can eliminate as much parameters as we can, so that we can only have one unknown in our equation, diba? If we take moments at b, automatically the moments for b sub y and b sub x are not included in the equation. And as you can see, only a sub y will be included in the moment equation. And that will be the only unknown for that particular process. So summation moments at b equals 0. So starting off with the 600-pound force, so again, times 12, di ba? So times 12 feet, then this will create a counterclockwise rotation. So this is a positive moment. So this is 600 times 12. So positive 600 times 12. So next is we can analyze the 240-pound force. So how are we going to determine the distance? So from B, this is the distance. The perpendicular distance is 16, di ba? So this distance, so we can transfer the distance at the tail of 240-pound force, and the distance is 16. So if we're going to push again this force against the tail, so it will create a positive moment. So that would be a negative rotation. I mean a negative value since the rotation is clockwise. We're going to have minus 240 and then times 16 feet. So next is our a sub y. So the distance from point B is 24. So again, if we're going to push the tail, so the rotation will be clockwise. So that is negative. So negative a sub y times 24. And then lastly is the 400-pound force. That will be 36 on distance. Then the rotation that it will create is counterclockwise. So it is positive. So this is plus 400 times 36 equals 0. So again, notice that only ay is unknown, so we can now solve a sub y. So a sub y is equal to, so again, you can use your calculator, given that you are providing the equation right before using the calculator. So dili siya magically appeared na solution. Okay, so a sub y is 740 pounds. So to solve for the other vertical force, By and Bx, we're going to use summation of forces vertical, or y is equal to 0. So 400 going down is negative 400. Then ay is positive. Then plus by is positive. And then negative 600 going down equals 0. So minus 400 plus 740 plus by minus 600 equals 0. So by is equal to 260 pounds. Then lastly is your summation forces x. So of course, is as you can see in the drawing, there's only one horizontal component, one external horizontal force. So it's automatically the same as bx, diba? But if you're going to verify this one through equation, so 240 minus bx, because bx is going to the left, so bx is equal to 240 pounds. So that's how you solve your truss system, the equations or the reaction forces for your truss system. Okay, so questions or clarifications? Okay, so okay, since gamay raman tanya, kamo raman ang nakakaroon, so ako lang ning upload later on a much later date ang recording kay para ano half ra ang present. Okay, so last problem before we dismiss. So after this one is I already published the assignment dito sa Canvas. Okay, so again, roller for Masanay Ligid, it's a roller. And this one is a hinge. So vertical. Then as you can see in the external force, 30 going to the right. So it's safe to say that the reaction force of the hinge is going to the left to negate this 30 Newton, 30 kilonewton force going to the right. This one is A sub y, this one is B sub y, and then B sub x. So again, taking moments about B first to eliminate first the two unknown forces. So this will be summation moments about B equals 0. So let's start from left to right. So 4 plus 3 plus 3, that will be 10. And 10 times 60, this will create a counterclockwise rotation. So this is 60 times 10. So next is your AY, A sub y. So the distance from B is 7. And this will create a clockwise rotation. So this will be negative. So AY then times 7. So next is your 120 kilonewton force downwards. This will create a positive moment, which is a counterclockwise direction. So we have plus 120 times 4. So again, by and bx are not included because it's collinear at the point. So next is your 30 kilonewton force. So this will create a negative moment because it's a clockwise direction moment. So this will be negative 30, then the direction going towards point G from B is 4. And then the last one is a negative moment again. It's clockwise direction. So minus 50 times 4 equals 0. So notice AY is the only unknown parameter. Okay, so 108.37 pounds. Patay verify kay murag. Okay, so 108.57 yun is, yeah. This is for A sub y. So to solve for your B sub y, so summation forces y equals 0. So negative, so from left to right, negative 60 going downwards, positive AY, then negative 120 going downwards, and let's say positive BY, then negative 50 equals 0. So the reaction at BY, let me correct this one first. Oops. Dali sa okay, so negative 60, then plus, so I think I cannot erase this one anymore. Then 108.57, then minus 120 plus by minus 50 is equal to 0. So b sub y is so notice that your b sub y is 121.43. So notice that it's a much wala. Oo, kalimot ko. So nagkuha na kay press something. Isa so kanya siya. This is your by. So notice that your by is a greater value of ay. So meaning the hinge support is supporting more of the vertical load compared to a sub y. Then lastly is for your summation forces x equals 0. So automatically you have 30, then minus bx equals 0. So bx is equal to 30 kilonewton. Mali niya itong 30 kilonewton. Anad ko sige og kuan. So this one is kilonewton. This one is also in kilonewton. That's how you solve your reactions. So do you have questions or clarifications? So are you not confused on the rotations of the moments?